Hello everyone. In this video, we are going to see an introduction to Terraform. First, let's see the different ways to manage infrastructure. I'm taking an example of Azure. There are broadly two ways to create and manage infrastructure. They are manual approach and automated approach. Let's assume that you would like to create 3 storage accounts in Azure for development, testing, and production environments. If you are using manual approach, first you need to log in into Azure portal. Next, you need to create storage account by filling all the required information such as name, location, and replication type. And you will create a storage account in the development environment. To set up the storage account in test and the production environment, you need to repeat the same steps every time. Whereas in the automated approach, with tools like Terraform, you can write code and define the storage account configuration once, and the same code can be reused to deploy the storage account across different environments. You just have to update variables like name or location, making the process faster, consistent, and scalable. Now let's see what is infrastructure as a code. Instead of managing the infrastructure through manual steps, infrastructure as a code allows us to manage the infrastructure with code. This makes infrastructure setup works like software development. We can make advantage of version controlling, repeatable and easy to manage. Tools like Terraform automates resource provisioning, making deployment faster and reducing human errors. The key benefits of IAC includes consistency across environment, repeatability of deployments, and scalability to meet growing business needs. So why we use Terraform? Terraform provides one language and one workflow across all major clouds. That means that you can provision resources in Azure, AWS, and GCP using the same tool. It allows you to use standardized templates, ensuring uniform infrastructure across different providers. With Terraform, scaling infrastructure up and down in any cloud becomes simple and efficient. By eliminating manual steps, Terraform helps to reduce errors and speed up provisioning. Since infrastructure is treated as code, you can track changes, roll back if needed, and collaborate just like in software development. And finally, Terraform enables you to deploy hybrid or multi-cloud architecture using a single configuration, making it both powerful and flexible. Now let's see what is Terraform. Terraform is an open source infrastructure as a code tool created by HashiCorp. It uses HCL or HashiCorp configuration language to define infrastructure in simple and human readable way. With Terraform, you can provision and manage resources across Azure, AWS, GCP, Kubernetes, and many more platforms, all with the same workflow. It automates the entire lifecycle of your infrastructure, including deployment, updates, and teardowns. Most importantly, Terraform ensures consistency, repeatability, and scalability, making infrastructure management fast, more reliable, and easy to maintain. In short, Terraform is a tool to manage infrastructure as code across multiple clouds. Now let's take a look at Terraform architecture. You begin by writing your infrastructure definitions in Terraform configuration file, which uses .tf extension. These files describe what your infrastructure should look like. For example, virtual machine, networks, or databases. These configuration files are written in HCL, that is HashiCorp configuration language, which defines the desired state of resources such as Azure VM, AWS EC2 instance, or GCP storage bucket. The core of Terraform is the Terraform core engine. This is the heart of the system. Its main responsibility is to read the .tf files, build an execution plan with the Terraform plan, interact with the providers, And finally, update the state file. Now, Terraform doesn't directly talks with Azure, AWS or GCP. Instead, it uses providers. The providers acts as a plugin that translates Terraform instructions into real API calls for each cloud platform. Finally, we have Terraform state file, also known as .tf state file. This file records the current state of your infrastructure. It helps Terraform understand what already exists, what needs to change, and prevents duplication. The state can be stored locally on your machine or remotely in backends such as Azure Storage, AWS S3, Google Cloud Storage, or Terraform Cloud. And this is how Terraform architecture works. A smooth flow from configuration file through the core engine to providers and the state file, keeping everything in sync. I hope you got the fair idea of the introduction of Terraform and its architecture. In the upcoming videos, we will see the practical implementation. I hope you like this video and I'm sure that you learned something new today. If you do like this video, please consider to subscribe and I will see you in yet another interesting video. Thank you.